Okay, following on from the previous video, we are on Mars. We're going to fire a cannonball at 15. Gravity on Mars is this, and then we're going to try and find out the height of the cannonball after 6 seconds. Okay. Normally I would ask you to work out the maximum height and then jump to the free fall formula to work out the distance traveled here. But now we're going to do a new technique, which is more efficient. Okay. Okay. So given this problem here, jump to your velocity time graph. So hang on. So your velocity time graph would look like this. Okay. The intercept is 15 here. The time at maximum height is this time here. Okay. Now, because we want to find out when you get given this problem, you won't know when the maximum height will occur. You have to use this to try and figure it out. So once we got our number here, 4.4, you know inside your mind that it takes 4.04 seconds to get to the maximum height. Now 6 would be somewhere over here, so you know there's going to be a downward distance as well. So when you first get given this without the velocity time graph, you won't know where 6 seconds. You won't know if that's after the maximum height or before the maximum height. You won't know. You need to jump to your velocity time graph, work out the time it takes to get to the maximum height. Then inside your mind you get a picture of when it will reach its maximum height. So it will reach a maximum height of at 4.04 seconds. That means because we're trying to find out the distance above ground after 6 seconds, then you know, because 6 seconds is after this, so you know there will be a downward distance. Normally I would ask you to jump to the free fall formula, but now we're going to use a new technique. So 6, let's just say 6 is at this point here. We're just going to use the trapezium rule to work out the total area here when you merge the two areas here. Now the area here will be negative. That's why it works so well. This is why velocity is so much better than speed time graph. The speed time graph will look like this, and you won't be able to use the trapezium rule here because it just won't work. Here with velocity, this area here will be negative. So the trapezium works perfectly with the velocity time graph. It won't work with speed time graph. That's why we abandoned it. Okay, so now let's just use your trapezium rule. It will still work. So put the 6 into this thing here. Okay, so we know the height here. We need to know this height here at 6. So we need to know this point here. Okay, so let's put 6 into here. So I did this before in the previous video, but I can't remember. So let's do it again. So 15 minus 3.71 and times 6, because we are putting the 6 here into the t, okay, to find out what the velocity will be at time equals 6. So now jump to my rubbish calculator, clear this. So it would be hang on, let me do 3.71 times 6 equals this. So this will be 15 take away 22.26. So that would be, hang on, calculator, clear this. 15 take away 22.26 equals negative 7.26. Now, even though this distance here is a negative, what was it? 7.26. Even though this is a negative, the trapezium still works. So let's just get the height here. plus this here, and then divided by 2 to get the average, and then times 6. Okay, because normally if you have a trapezium here, you would just get this plus this divided by 2 to get the average, and then times this thing here. So the average is somewhere in the middle here. Well, the average here still works. It will be somewhere around here, but it will still work. So let's just work out the total area here. So the height here would be 15. So 15 plus this thing here plus a negative. So it will be the same as negative well minus this, and then divided by 2, and then we're going to times 6. Okay, so let's just do it on a calculator. So this thing here, so the whole area here equals this. So this equals, hang on, calculator. Clear this. So it would be 15 minus 7.62 equals this, divided by 2 equals this, times 6 equals this, 23.22. So the total area is given by this. So this total area is given by what was it? 23.22. That means this height after 6 seconds will be 23.22. And by the way, this the distance covered by the free fall is this small triangle here. Okay, and this big triangle here represents the distance. Well, basically, when you have, because this is a negative, this is because it's going downwards, then this will be a negative. Well, all you have to do is work out the area underneath this graph. Okay, and when you're older, you would do what's called integration. It will give you the area straight away. Well, anyway, don't worry about it. Just know that the trapezium rule still works, even if it's on the negative side. Okay.